And this time we are going to skim together a book titled Beginning Serverless Computing by Maddie Stigler. It's about developing with Amazon Web Services, AWS, Microsoft Azure, MS Azure, and Google Cloud, the famous Firebase, right? Let's go through that. So basically, it was published in 2018. And let's go through that book really quick. Here's the table of contents. Chapter 1, it's talking about understanding serverless computing. So it answers the question, what is serverless computing? And it answers what is it different, how it is different. And it talks about the benefits and use cases and limits to serverless computing, right? Then conclusion, chapter 2 talks about getting started, what each provider offers, and because the author is from a specific country, all the solutions are from that specific country, which is like that's normal in the scientific field, that it's kind of advertising your belonged fella, right? So yeah, exploring what each provider offers. It talks about the Amazon, the Microsoft, and the Google products, and it talks about explore triggers and events, development options, toolkits, and SDKs, and developing locally versus using console, and the tools, right? Node.js, Postman, yeah, and environment setup. And the conclusion, chapter 3 talks about the AWS services, and it talks about the user interface, the security, the first code, the environment variables, the HTTP events, storage events, and after the conclusion, we have chapter 4 talks about the second product. We covered AWS from Amazon. The second one is going to cover Azure from Microsoft. Again, exploring the user interface, security, first code, HTTP events, storage events, and conclusion. And the third one is Google Cloud, and exploring the user interface, the security, the first code, same process, same titles, HTTP event, storage events, pub sub events, and conclusion. Here's something called pub sub. What is Google Cloud pub sub? Creating our pub sub function, right? And chapter 6 is about an agnostic approach, need for agnostic solutions. And that's the end of the book. So the book is less than 200 pages. And here's the author, here's the technical reviewer, and chapter 1, understanding serverless computing. Serverless architecture encompasses many things, and before jumping into creating serverless applications, it is, so basically, this applies to both web-based and mobile apps, right? It is important to understand exactly, and I think desktop apps, all right? It's important, of course, it's desktop apps included. It's important to understand exactly what serverless computing is, how it works, and the benefit using and use cases of serverless computing. Sorry about that. Generally, when people think of serverless computing, they tend to think of application with backends that run on a third-party services, also described as a code running on ephemeral containers. In my experience, many businesses, and the author's experience, many businesses and people who are new to serverless computing will consider serverless applications to be simply in the cloud. while the cloud is basically a data center that belongs to some company, right? While most serverless applications are located in the cloud, it is misperception that these applications are entirely serverless. The application still run on servers that are simply managed by another party, of course. Two of the most popular examples of this are AWS Lambda and Azure Functions. So we have AWS, Amazon Web Services, Lambda, and we have Azure Functions. They are both serverless computing. We will explore these later with hands-on examples, and we'll also look into Google's Cloud Functions. What is serverless computing? Serverless computing is a technology known as function as a service, FaaS. So they provide a service that gives the cloud provider complete management over the container the functions run on as necessary to serve requests. By doing so, these architectures remove the need for continuously running systems and serve as event-driven computation. The feasibility, keep this in mind, event-driven computation. The feasibility of creating scalable applications within this architecture is huge. Imagine having the ability to simply write code, upload it, and run it without having to worry about any underlying infrastructure setup or environment maintenance. The possibilities are endless, and the speed of development increases rapidly. By utilizing serverless architecture, you can push out fully functional and scalable applications in half the time it takes you to build them on the ground up. Serverless as an event-driven computation. That's why we highlighted in the previous paragraph. Event-driven computation is an architecture pattern that emphasizes action in response to or based on a reception of events. This pattern promotes loosely coupled services and ensures that a function executes only when it is triggered. So what is event-driven computation? The function executed only when it is triggered, does not need to check periodically or do anything similar to that. It also encourages developers to think about the types of event and responses a function needs in order to handle these events before programming the function. In this event-driven architecture, the functions are event consumers because they are expected to come alive when an event occurs and are responsible for processing it. Some examples of events that trigger serverless functions. So here's an event that triggers serverless functions includes these. API request, application program interface request, object puts and retrievals in object storage, changes to database items, scheduled events, voice commands, for example, Amazon Alexa, bots like robots, such as AWS Lexa and Azure Lewis, both natural language processing engines. Figure 1.1 illustrates an example of an event-driven function execution using AWS Lambda and a method request to API gateway. And here is it. So here is a mobile app or a website. And here is the API gateway and the Amazon Lambda and the Dynamo database, right? All right, we'll skip that part because we are skimming just to avoid having the video or the recording boring. Functions as a service. So selling a service, right? And function as a service, F upper capital or uppercase, then AA both on a small or lowercase, then the S is capital or uppercase. This is called function as a service. Function as a service is often, depends, right? It's often how serverless technology is described. So it is good to study the concept in a little more detail. You may have also heard about IaaS, infrastructure as a service, PaaS, platform as a service, and SaaS, software as a service, as cloud computer service models. So we have the function as a service, we have the function as a service, and this is highlighted here, the infrastructure as a service, and the platform as a service, and of course SaaS, which is software as a service, as cloud computing service models. So all these are service models used in cloud computing. Infrastructure as a service provides you with the computing infrastructure, physical or virtual machines, and other resources like virtual machines, disk image library, block, file-based storage, firewalls, load balancers, IP addresses, virtual local area networks, etc. An example of this is Amazon Elastic Computing Cloud, Elastic Compute Cloud instance, that's called EC2. So what is EC2? It's Elastic Computing Cloud. Who owns that service? It's Amazon Corporation. What model does it follow? It uses the IaaS. What does IaaS mean? It means infrastructure as a service. P, so we talked about IaaS. Now let's talk about platform. IaaS provides you with computing platform, which typically includes the operating system, programming language execution environment. So it's like developing environment. Database and web server. Some examples include AWS Elastic Beanstalk, Azure Web Apps, and Heroku. All right, so we talked about this one. Infrastructure as a service. We talked about this platform as a service. And here is the third one, which is software as a service, provides you with the access to application software. The installation and setup are removed from the process and you are left with the application. Some examples of this include Salesforce and Workday. So SaaS, Workday is an example of that, and Salesforce also, and they are software as a service, right? So now we have functions as a service, like cloud computing, and we have the infrastructure as a service, like the data center is rented and it's empty, and you have the platform as a service, like the developing environment is rented and it's empty, and you have the software as a service that they rent you, they let you use a software through a website or so, like a Workday. And function as a service entails running back-end code. Sorry, let's reread this. Function as a service entails running back-end code without the task of developing and deploying your own server applications and server systems. All of this is handled by third-party providers. We will discuss this later in this function. So we have this thing, right? And this figure 1.2, illustrates the key differences between the architectural trends we have discussed. We have the traditional IT, everything is in-house. We will have the infrastructure as a service. So the network, storage, servers, and virtualizations are provided as a service. And we have the platform as a service, similar to the infrastructure as a service, but the operating system, the middleware, and the runtime, like the developing environment, are also provided as a service. The software as a service, everything is provided for a specific application. So all these are provided. The function as a service, everything is provided except the application, right? And this is the cloud computing, this one, the right-hand one, all right? Let's proceed. How does serverless computing works? We know that serverless computing is an event-driven FaaS, function as a service. But how does it work from the vantage point of cloud provider? How our servers are provisioned, auto-scaled, and located to make function as a service platform a point. So basically, we have a group of questions of, okay, I get the idea how to do that, right? And all these questions are raised here. A point of misunderstanding is to think that serverless computing does not require servers. This is incorrect. Serverless functions still run on servers, of course, but it's not our servers. The difference is that a third party is managing them instead of the developer. So you are storing your work, your sweat, in somebody else's bucket, right? To explain this, we will use an example of traditional three-tier system with server-side logic and show how it would be different using serverless architecture. Let's say we have a website where we can search and purchase textbooks. In traditional architecture, you might have a client, load balancer server, and database for textbooks, right? This is the traditional. So you own the full cycle. The configuration of serverless is the servers are spun up and down based on demand. How it is different, how serverless computing different from spinning up servers and building infrastructure from the ground up. We know that the major difference is relying on third-party vendors to maintain your servers. But how does that make a difference in your overall application and development process? The main two differences you are likely to see are in the development of applications and independent processes that are used to create them. So development and independent processes. All right. The development process for serverless applications changes slightly from the way one would develop a system on premises. Aspects of the development environment, including IDE, source control, versioning, and deploying options, can all be established by the developer, either on premises or with the cloud provider. So the developer does all that. A preferred method of continuous development includes writing serverless functions using IDEs such as Visual Studio, Eclipse, IntelliJ, and so all these are IDEs, right? And deploying it in small pieces to the cloud provider using the cloud provider's command line interface. So we have something called command line interface. If the functions are small enough, they can be developed within the actual cloud provider's portal. We will walk through the uploading process in later chapters to give you a feel for difference between development environments as well as the difference in providers. However, most have a limit on function size, so it's limited, before requiring zip upload of the project. So what is the command line interface? The command line interface is a powerful development tool because it makes serverless functions and their necessary services easily deployable and allows you to continuous using the development tools you want to use to write and produce your code. All right, so now we know what is the command line interface. Here is the command line interface definition. The serverless framework tool is another development option that can handle using NPM. You will see in greater details later in this chapter. What is the independent processes? So remember here we mentioned two things, how it's different and says it's different in the development applications and in development of applications and independent processes that were used to create them. And here's the development that we talked about, and it talks about the CLI, command line interface, and the independent services. It's another way to think of serverless computer. Another way to think of serverless functions is a serverless micro services. Each function serves its own purpose and completes process independently of other functions. Serverless computing is stateless and event-based. So this is how the function should be developed as well. For instance, in traditional architecture-based API operations, get, post, put, delete, you might have object-based models with these methods defined on each object. The idea of maintaining modularity still applies in serverless level. Each function could represent an API method and perform one process. Serverless framework helps you with this, as it enforces smaller functions, which will help focus your code and keep it modular. Like it makes the full image as small puzzle pieces, small functions. Function should be lightweight, scalable, and should serve a single purpose. To help explain why the idea of independent process is preferred, we will look at different architectural styles and the changes that have been made to them over time. Figure 1.1-5 illustrates the design of monolithic architecture. And this is independent services. So they used to be merged together, depend on each others. Now they are separated. The microservices approach breaks away from the monolithic approach pattern by separating services into independent components that are created, deployed, and maintained apart from one another. Many of the concerns that we saw with the monolithic approach are addressed through this solution. Benefit and use cases. One thing many developers and large businesses struggle with about serverless architecture is giving cloud providers a complete control over the platform of your services. However, there are many reasons to use cases that make this good decision that can benefit the overall outcome of the solution. Some of the benefits include rapid development and deployment, ease of use, lower cost, enhanced scalability, no maintenance of infrastructure. So this book is basically an ad for these three products from these three big whales, from these three big giant companies, organizations. So it's the whole thing is like an ad, right? So they won't mention anything negative, just to be objective and do not let the details drag you, Rapid development and deployment. Since all the infrastructure, maintenance, and auto-scaling are handled by the cloud provider, the development time is much quicker and deployment is much easier than before. The developer is responsible only for the application itself, removing the need to plan for time to spend on server setup. AWS and Google also provide function templates that can be used to create an executable functions immediately. Deployment also becomes a lot simpler, thus making it faster process. These cloud providers have built-in versioning and aliasing for developers to use to work and deploy in different environments. So rapid development, ease of use, lower cost, right? Prices for function execution by cloud provider as publications. The first million requests a month is free. First million requests a month is free. First 2 million requests a month is free. 20 cents, 20 cents, 40 cents. And this is the charge for every gigabyte per second. This is the charge, and this is the charge. So they charge by request. They charge by the storage, right? Enhanced scalability. Scalability means expansion, right? And understanding serverless computing, and you see how it's globally used. Let's magnify this or zoom it a little bit. So this is the, by color, this is the AWS, Amazon Web Services. This is the Microsoft Azure, and this is the IBM, and this is the Google. Now we have IBM here, right? And how they are widely used. Existing and planned, right? So basically they are planning to control the whole entire world, right? Netflix case study with AWS. Netflix case study. Netflix is also American, and Amazon Web Services are also American. Netflix, a leader in video streaming services with no technology, went with a serverless architecture to automate the encoding process of media files, the validation of backup completions and instance deployment at scale, and monitoring of AWS resources used by the organization. To apply this, Netflix created triggering events to their Lambda functions that synchronized actions in production to the disaster recovery side. They also made improvements in automation with their dashboards and production monitoring. Netflix accomplished this by using triggering events to prove the configuration was actually applicable. Limits to serverless computing. If you want control of your infrastructure, you are designing for long-running server applications. You want to avoid vendor lock-in. You are worried about the effect of cloud start. You want to implement a shared infrastructure. There are a limited number of out-of-the-box tools to test and deploy locally. So some of these limits are, we just read here. Of course, they will not mention everything, right? Control of infrastructure, so each one of these is covered. Each one of these is covered in the few sections, right? Vendor lock-in, cold start, share services, limit number of testing tools, right? And here's the chapter conclusion. In the next video, we'll be talking about chapter 2, getting started. See you later.